The figure represents the cylinder with two radii A and B. We have the dot R that is somewhere in between A and B, and the dashed line is the Amperian loop that we're going to consider so that the current is popping outside the page towards us. In order for that to happen, we need to assume a direction of the current. So let's assume the current is going arbitrarily clockwise. And because the current depends on the location R, we can't just do a proportionality. We have to do an integral. So I enclosed is the integral of the density times an area element dA. If we look at the loop and we consider its circumference 2 pi r, and we take a small thickness dr, then if we integrate from A to R, we can get all the currents inside from A to this R, which is the Amperian loop. So we can say this is equal to from A to R of CR squared, which is J, times the area element, which is its circumference times its thickness, or length times width if you want. So this gives us the integral from A to R of 2 pi c r cubed dr. And since 2 pi c is a constant, we can pull that out and say we have 2 pi c times the integral from A to R of r cubed over dr, sorry. And we know this gives us 2 pi c r to the fourth over 4 between A and R, which means this is 2 pi c r to the fourth minus A to the fourth over 4, or the same as pi c r to the fourth minus A to the fourth all over 2. Now, Ampere's law says that the integral around a loop of d dot dl is the same as mu times I enclosed. And if we want to take B and L to be in the same direction, we can use that fact to get that the current, in order for the current to be out of the page, we need this current density to be a negative in order for our equation to work, in order to get B and L in the same direction. So we can get integral B dl cosine 0, I'll leave that out, equals mu naught. Instead of I closed, we're going to put minus pi c over 2 r to the fourth minus A to the fourth. And this becomes B times 2 pi r, right? Because the B can go out. Integral of dl is 2 pi l. It's the loop, minus mu naught pi c r to the fourth minus A to the fourth all over 2. And now if we divide or solve for B, we get that B is mu naught c over 4 r times r to the fourth minus a to the fourth. And we have all of these values, so we can plug in. Mu naught is 4 pi times 10 to the minus 7th Tesla meter per amp. C is given as 3.0 times 10 to the 6th amp per meter to the fourth, all over 4 times R, which is 3 centimeters. Oops. So it's 0.03 meters times 0.03 meters quantity to the fourth minus A, which is 2.0 or 0.020 meters to the fourth. And if we multiply these out, we get about negative 2.0 times 10 to the minus 5th Tesla. And its magnitude is 2.0 times 10 to the negative 5th Tesla, as we said. So if this minus sign is confusing, you can just ignore it and treat this as a positive throughout, and you'll be fine as well. Because we arbitrarily picked the direction to be clockwise, we could have done it counterclockwise and gotten the same answer.